This Zoom session is brought to you by the Fractal Hex Quilt C. All right, 5, 5. All right, we're going on 5, 5 and 5, 6. 5, 5 is about the greatest common factor and factoring by grouping. We have two numbers, such as say 4 and 6. Their greatest common factor is the largest number, or GCF, is the largest number that divides into both of them. And their least common multiple, LCM, is the smallest number that they both divide into. Now, people get them confused because the word greatest, when they say 4 and 6, the greatest, was that 12? No, it's 2. Least common multiple, well, it's least, but that doesn't mean it's below. It's in fact bigger. So it's not 2, it's 12. Okay. So LCM is the biggest, is the smallest number that they both divide into. GCF is the largest number that divides into both. Now, okay, we don't want it, and GCFs and LCMs don't apply just to numbers, they apply to terms, where there's a coefficient and variables to powers. So for example, okay, so now one way to find greatest common factors and least common multiples involves primes. For example, 4 is 2 to the second times 3 to the 0. 6 is 2 to the 1 times 3 to the 1. The least common multiple is a product of primes to the bigger powers. So for example, here's a 2 and a 1, we put 2 for the 2. Here's a 0 and a 1, here put a 1 for the 3. 2 to the second times 3 to the first is 12. The greatest common factor is a product of powers, primes to lesser powers. So here's a 2 to the 2, 2 to the 1, we put a 1 here. 3 to the 0, 3 to the 1, we put a 0 here. 2 to the 1 times 3 to the 0 is 2. Well, let's take another pair of numbers, 18 and 60. Find their least common multiple and their greatest common factor. 18 has powers 1, 2, and 0. 60 has powers 2, 1, and 0. So, oh dear, that's 5 to the first. My error. 5, 5, 2. 5 to the first. My mistake, so I get on it. Anyhow, for the LCM, we take the greater of the two powers. 2 to the 1, 2 to the second, 2 to the second. 3 to the second, 3 to the first, 3 to the second. 5 to the 0, 5. This should be a 2 or 1. 5 to the 1, 2 squared, 3 squared times 5 is 180. For GCF, we take the lesser of the two powers. 1 and 2, 2 to the 1. 2 and 1, 3 to the 1. 0 and there should be a 1, 5 to the 0. 2 to the 1 times 3 to the 1 times 5 to the 0 is 6. So that's how using prime factorizations to find common LCMs and GCFs. There's also another method for finding GCF and LCM. There's the Euclidean algorithm. You'll see that in the extra credit module. In fact, I could do that in just a moment. Let's show you somewhere around here. It's down in here in the extra credit section. Just a second. There you go. Euclidean algorithm. It's a problem, a tutorial and a problem set. That's extra credit for you. Okay, let's go back to this. All right. Now, algebraic terms also have GCFs and LCMs. The GCF of two terms, such as this and this, has the GCF of the coefficients times variables to the lesser powers. LCM, least common multiple, has least common multiple coefficients and times variables to greater powers. So for example, least common multiple of 18x to the 5th, y to the 4th, and 60 y to the 2nd, z to the 7th. 18 and 60, their least common multiple is 180. We have x to the 5 and x to the 2. We use the greater power, x to the 5. Here's y to the 4, y to the 7th. We use the greater power, y to the 7th. Or 18, x to the 5th. This should be a times y to the 4th. Excuse me while I make a note. 5, 5, 3. Okay. Anyhow, and okay, 8y to the 5th, x to the 4th, 60x squared, y to the 7th. 18 and 60, their greatest common factor is 6. And we have a 5 and a 2, we put a y to the x to the 2nd. We have y to the 4th, y to the 7th, we put a y to the 4th. Okay, so here's an example from 5.5, number 17. Find the greatest common factor, which is what we'll be mostly using in this section, of 24 r to the 3rd, z to the s to the 5th, 36 r to the 8th, s to the 4, 48 r to the 4, s to the 4. Now, all right, greatest common factor. It's the biggest number that divides into 24, 36, and 48. All right, it's 12. 12 goes into 24 twice, it goes into 36 3 times, it goes into 48 4 times. And no bigger number goes into all of them. Now, if we look at the least power for each, R3, R8, R4, we put R3. S5, S4, S4, we put S4. So the greatest common factor is 12R to the 3rd, S to the 4th. And we're going to use this as a way of reducing fractions. And we factor by removing a common factor is if you have a whole bunch of terms with a common factor of x, we can pull it out times the sum of the other terms remaining, a plus b plus all the way up to z times x. This is called a complete factorization if x is the greatest common factor of all terms. So you can't pull any other factors out. So here are some examples. 24x plus 16. The idea of all these is to remove the greatest common factor. Well, 8 goes into 24 3 times. It goes into 16 twice. No bigger number will do. So we pull out a factor of 8 times 3x plus 2. We have a 45a squared minus 9a. 9 goes to 45 and 9, so we pull out a 9. Here we have an a squared and a to the 1st, so we pull out an a. And what's left is 45a squared over 9a is 5a minus 9a over 9a is 1. 9a times 5a minus 1. That's the factorization. We have 15x squared y minus 10x squared y squared. 15 and 10 have a greatest common factor of 5. Now here we have a common x squared, so we pull that out. We have a y and a y squared, the lower power is y, so we pull out a y. And we have 15x squared y, and then if we divide these two terms by 5x squared y, we're left with 3 minus 2y. So 5x squared y times 3 minus 2y. Here's a bit of a trick question. 14r plus 15, what common factor? Well, the best you can do is 1. 14 and 15 are what are called relatively prime. There's no common factor. So this term as a whole can't be reduced, and it's what's called a prime. It's a prime expression. All right. Now, there's something called, the book calls factoring by grouping, and I call it unfoil. It works for a very special thing like this. There's 4 terms, ax plus bx plus ay plus by. The idea is we factor it pairs of terms at a time. Ax plus bx have a common factor of x. We pull that out times an a plus b. Ay plus by have a common factor of y. We pull that out and we're left with a plus b. Now it so happens that this is arranged so that there is now a common factor of a plus b. This is 2 terms. This term has an a plus b factor, so does this. So we pull it out, a plus b times what remains, which is x plus y. A plus b times x plus y. So we group twice and factor twice, and that's that. Now, going from the bottom to the top is called FOIL, first, outer, inner, last. So that's why I call this unfoil. So here's some examples. AX plus 8x plus AY plus 8y. Well, obviously these 2 factors have a common factor of x, out it comes, times an a plus 8. AY plus 8y have a common factor of y, pull that out, left with a plus 8. And okay, here we have an a plus 8 in common. We pull that out and left with x plus y. So a plus 8 times x plus y. Here we have minus 18a squared b plus 12ab squared. The idea is to pull out the greatest common factor. Now, 18 and 12, their greatest common factor is 6. We have an a squared and an a, so we pull out a to the first. We have a b to the first and a b squared, so we pull out a b to the first. And I make it negative. That's optional, really. So pull out a factor of minus 6ab. Then these two terms will be these two terms divided by negative 6ab. Minus 18a squared b over negative 6ab leaves you 3a. 12a squared b over negative 6ab leaves you negative 2b. And that's the factorization. Here we have t cubed minus 3t squared minus 7t plus 21. What's that? Can you factor it? Well, okay. Now this, okay, fine. These two terms, t cubed and 3t squared, have a common factor of t squared, which you pull out, leaving behind t minus 3. You have a minus 7t plus 21. These have a common factor of 7, leaving behind minus t plus 3. Now, we're not quite right. This is t minus 3, and this is negative 3, negative t plus 3. They are not quite the same, but all they differ by is a factor of negative 1. So what we do is we pull out a negative 1 factor, and that flips the sign in here. So we have t minus 3 times t squared minus t minus 3 times 7. Now we have a common factor of t minus 3. Here it is, leaving behind t squared minus 7 here. So t minus 3 times t squared minus 7. Okay. Here's 4 terms, mpx plus mqx plus npx plus nqx. What's that? All right, these all have a common factor of x. So pull out x times mp plus nq plus np plus nq. Now this we can unfoil, factor by grouping. These first two terms are mp plus mq. Out comes a common factor of m times p plus q. Here. These two terms, np plus nq, have a common factor of n, pull it out, times p plus q, here. Now in here, there's a common factor of p plus q. We have x times p plus q times m plus n, this. Negative 63u cubed plus 28u squared is what? Well, okay. Negative 63 and 28 have a common factor of 7. U to the third and u squared, well, the lower power is u squared, so pull out that. So minus 7u squared times, and then you divide each of these terms by minus 7u squared, you get 9u minus 4, like this. Okay, this next one, well, these next two really involve removing common factors and so on. This is as a way towards solving an equation. Later on, we'll be solving lots of equations by factoring. Here are a couple here. We have Rx minus Ty equals By. Solve for y. Now the difficulty is that y is on both sides of the equation. That can be fixed. We transpose the Ty by adding it to both sides. We get Rx equals By plus Ty. Now here we have y in two places. Well, we can remedy that by pulling out that it has a common factor times what's remained, b plus t. So Rx equals b plus t times y. Now to find y, we isolate it by dividing by b plus t. And we get Rx over b plus t equals y. And that's the solution. Here we have the equation s times 1 minus r equals a minus lr. All right, then, what is r? This colon is just punctuation. I've seen people get confused. Is that a times, a divide? No, it's just punctuation. Here's one sentence. Here's another sentence. All right, so we want to solve for r. Okay, the difficulty here is that, well, first of all, r is on both sides of the equation. And second, here r is inside a parenthesis. Well, okay, first step, we'll dissolve the parenthesis by distributing s over both terms. We get that, we get s minus s times r. That equals a minus lr. Okay, we're going to move the s to the right by subtracting it from both sides. Move the LR to the left by adding it to both sides. And what happens is you get LR minus SR equals A minus S. Now, we have R on one side, but in two places, but that can be remedied by removing it as a common factor. So R comes out times L minus S. L minus S times R equals A minus S. To solve for R, we divide both sides by L minus S. We get R equals A minus S over L minus S. All right.